Okay, so in this problem, we're going to be graphing y equals negative cotangent of 1/3 x minus pi all plus 2. So the first thing that we need to do is take care of all of our horizontal transformations, which occur inside of our trig function. So we're going to take this 1/3 x minus pi, and we're going to set it between one period of cotangent. And one period of cotangent is from 0 to pi. So remember, one period of tangent lies between negative pi over 2 and pi over 2. One period of cotangent lies between 0 and pi. Now we just want to solve for x. So the first thing that we're going to do here is add pi to all three. Which gives us pi is less than 1/3 x, which is less than 2 pi. And now we want to get rid of this 1/3, so we're going to multiply everything by 3. Which gives us 3 pi is less than x, which is less than 6 pi. Now this represents one period of our new graph of cotangent. This takes care of all of our horizontal transformations. So it's at this point that we can now find the actual period. So remember that the period for sine and cosine is 2 pi over b, but the period for tangent and cotangent is just pi over b. And in this case, b is our 1/3, so we get pi over 1/3, which, when you're dividing by a fraction, it's the same as multiplying by the reciprocal, so we get 3 over 1 instead of 1/3 times pi, or just 3 pi for one period. So our new period is 3 pi, and it's at this point that we now need to find a table or create a table for our x and cotangent of 1/3 x minus pi. So we start with our phase shift, which is this 3 pi on the left. And now we're going to add p over 4, the period divided by 4, to it 4 times. And that'll give us the 5 major values, basically our new quadrantal angles, taking into account our horizontal transformations. So we get p is 3 pi over 4. So p over 4 is 3 pi over 4. There's nothing to simplify there. So we'll add that to 3 pi 4 times. So off to the side, I'm going to convert 3 pi to have a base of 4. This way we can simplify it. So 3 pi is the same thing as 3 pi over 1. And now I'm going to multiply it by 4 to the top and multiply it by 4 to the bottom, which gives us 12 pi over 4. And now it'll be a lot easier to add 3 pi over 4 to it. So when we add 3 pi over 4 to it one time, we end up getting 15 pi over 4. If we add 3 pi over 4 to it another time, we're going to get 18 pi over 4, which will simplify to 9 pi over 2 if we divide the top and bottom by 2. If we add 3 pi over 4 to that again, we'll get 21 pi over 4. And now one more time, we'll get 24 pi over 4, which simplifies down to 6 pi. And remember, we always do a check. Do our first and last table values match up with our inequality? They do, which means more than likely we've done this correctly. In this case, we obviously have, but that's a quick check that you should always go through. Okay, so now remember these 5 values are very special because they have the same values as the quadrantal angles. So remember, cotangent and tangent always start and end with a vertical asymptote. So when we plug 3 pi and 6 pi in, we get an asymptote. And then cotangent always goes 1, 0, -1. Remember, tangent starts at -1 and then goes to 0 and +1. So we now need to just make our list of transformations, and from there we can start graphing it. So we'll quickly write out our transformations here. Okay, so starting with our first one, we have a negative being multiplied to the outside of our cotangent function. That means that we have a vertical reflection. And then from there, we have a 2 being added to the outside, which means that we're going to shift the function up 2. These are our only 2 vertical transformations. We've taken care of all the horizontal ones, so we don't need to worry about them. So now we can go about graphing this. So the first thing that we should do here is list our x-axis values. So we're going to start by just making a little note here. Whenever you put this little squiggly thing here, this is a way of saying that there's a jump in your graph. You're ignoring all of the x values between 0 up till what the first tick mark on your graph is. So we'll make that first tick mark, and we need it to start at 3 pi. So we'll make our tick mark 3 pi. And again, this symbol is telling us that we're skipping all the values between 0 and 3 pi. It doesn't mean that our tick marks are a distance of 3 pi apart, just that from the origin to this first tick mark, we've skipped all the values in between. Now we can start putting the rest of our tick marks in. Remember, we need 5 of them. And we have the first one after 3 pi is 15 pi over 4. The second one after 3 pi is going to be our 9 pi over 2. The fourth one out of all 5 is going to be 21 pi over 4. And finally, our last one is going to be 6 pi. So we'll start by writing out our vertical asymptotes, which we label with a dotted line. And now from there, we want to sketch out these points. So we have 15 pi over 4, comma 1. So we'll put a 1 on our y-axis and a -1 as well. So 15 pi over 4, comma 1. Then we have 9 pi over 2 comma 0. And finally 21 pi over 4 comma negative 1. And remember, all of our trig functions have a curve to them. So this isn't just a straight line. It's going to look like that. Now we just have to take care of a vertical reflection and a shift up 2, and we're all set. So I'll do my vertical reflection in red. Remember, a vertical reflection means you take anything above the x-axis and put it below, anything below and put it above. So this top part here is going to flip downward like so. And it always helps to redraw these key points. So this value of 1 on the y-axis will come down to negative 1. This point on the x-axis has a y value of 0. When you multiply it by negative, it stays right where it's at. And finally, this negative 1 multiplied by a negative gives us a positive 1. So our new graph looks like this. And now my final graph, I'll label in green. We need to shift the entire thing up 2. So we're going to need a couple more y-axis values. And we'll list the longest one up, or the highest one up. So this point down here, our lowest point, is going to go up 2, back to where it started. This one on the x-axis will go up 2 to a y value of 2. And finally, this point at y equals 1 will go up to y equals 3, giving us a final graph that looks somewhat like this. Oh, and that shouldn't have gone that far, but hopefully you understand that's just a little sketching typo. So, our final graph is what we see in green here. This is one period of cotangent. It lies between these two vertical asymptotes, and if we wanted to sketch any more periods, all we would have to do is travel a distance of 3 pi and then re-sketch the graph.